Welcome back. We are going to be taking a look at Advent of Code Day 20. It is officially the 20th, or at least it is 11 o'clock my time, so it's pretty late on the 19th, but it came out at 9 my time, so a couple hours have gone by. Anyways, we are going to be taking a look at Advent of Code Day 20. So here's a quick breakdown of what it looks like. We are given an input that looks like this, right? This is the file. We have a list of integers, and we're supposed to follow procedures, and basically every single one of these has an index, and we're supposed to go through based on their index, and the 1 will rotate 1 position, the 2 will rotate 2 positions, the 3 will rotate 3 positions, but it will rotate 3 positions the other way. The 3 will rotate 3 positions correctly, etc. So basically what we have is our initial arrangement, and we have to say, okay, we need to go through the entire list. Something that's really interesting here is that it's not just, oh, you go through the list, you rotate it based on the index of the value at that, based on the value at that index. No, you actually have to go through every single value and rotate based on the index of that of the item, and you'll get a sense of what I mean here as we dive on in. So first off, what we're going to do is we're going to take a look. Let's take a look. So we're actually going to have a combined solution for part 1 and part 2. This is because they're relatively similar, but there's some optimization that has to happen, or sort of optimization that has to happen. And the first thing, I've got our input, right? We're returning a list of all the different data points. But what I want to do here as well is I'm going to import from collections. We're going to, from collections, import a deck. Okay, and we're actually going to use decks in this case, and that is because we have to rotate, right? We have to rotate these things, and that's going to be really helpful for us because deck automatically has a rotate method, and decks are going to be a lot faster to deal with than lists anyways. So we're gonna deal with the decks instead. Okay, so we've got our input. That's our list of numbers. Okay, so let's do a combined solution. We're just gonna call this run. There we go. Okay, and we will need, because we need to keep track of the indexes, we're going to create a custom class that we're going to call num. So of course we're going to have an init function, and we're going to have index, and we're going to have a value, right? So this is where the original index, this is the original index of that value in that array. So we've got self.index is index, and we have self.value is value. And what we're going to do is we're going to receive the data here, right? And we're just going to have print run data, okay? Or rather, yeah, so we've got data is going to be parse data of the input. There we go. So we're going to run the data. So this is going to be essentially part 1, but we're going to abstract this out to cover both parts of day 20. Anyways, you'll see what I mean. So in this case, what we're going to have here is we're going to have we're going to iterate through every single index. We're going to iterate through every single index, and then we're going to rotate based off of the value for the item at that index. So we have our data here, right? And we're going to say for I in range, and we want the length of the data, right? And we're going to rotate that number, right? Whatever that number is. So in this case, we've got rotations. So first off, we need to, we basically need to rotate it to the front. So what we're going to do is we're going to rotate the value to the front, take that number to the front of the list. Then we need to determine how many more rotations we need. How many more rotations? to do rotate everything except the item, right? And then we're going to add the item, the number back in. And I'm going to use number here, because this is what we've got. We've got a num, right? And I use num because I don't want to get confused with number, but num. And we've got an index and we've got a value. Okay, so that's what we're gonna do. So first off, we need to find what the value is for that index. So we're going through the indices. So let's just do index here for index and range length data. And we're going to say rotations are going to be the number dot index for num in data. And we want to find the location of index I, index. See, that's not confusing at all, right? We've got 3 indices. I'm going to change this to an I, and hopefully that'll just be easier. Okay, so this is going through, and we want to get the index of this particular which index is this particular value at, because that's how many rotations we have to do. Now for rotations, if we want to rotate left, we have to use a negative number. If we want to rotate right, we have to use a positive number. So in this case, we have data.rotate. There we go. And we want to use negative rotations, right? Because we want to rotate left rather than right, or I guess your left rather than right? Okay. So how many more rotations do we actually need to do? Because obviously there's a limit to the length. Oh, we actually need to remove the value, right? So we're going to say that our value, or maybe we'll just say our num is data.pop left, and this is going to be the value, right? So this should be the value at the very front of our deck, of our list, and so we're going to remove that value. Okay, so now we need to figure out how many more rotations we need to do. So we've got rotations, and we're just going to reassign this value because we don't need to keep it from iteration to iteration. So we've got our number of rotations, and this is going to be the num dot value, right? This num that we just popped from the front of the rotation. This is going to be num dot value, and we're going to modulo that by the length of the data here. Okay, so this way we don't end up with an index that we have to rotate a certain number of times that's longer than the length of the data. I actually don't know if that would do anything. It might just continue rotating it anyways, regardless of whether that happens. Anyways, that's the number of rotations that we're going to do. So we're going to rotate everything except the number. So that's going to be this data, right? So we're going to do data.rotate negative rotations, right? Rotations. And then we just say data.append that number again, okay? And then the last part of this is that we need to find, here's what the answer is going to be. So wrapping around the list, we want to look at the 1000th number after 0. We want to look at the 2000th number after 0. And the 3000th number after the value 0. So the first thing we need to do is find the index of the value 0. This is actually fairly simple because we already did this for something similar for the rotations, right? So 0 index is going to be dot value, and that's where the index of 0 is going to be. And then we're going to return, and we just need to sum together those 3 values, right? So let's say we're just going to do this. And in this case, we're going to have data, and this is going to be our 0 index plus 1000, right? And we need to modulo that by the length of data, right? And we need to say, there we go. That plus 1000 modulo length of data dot value. right? And then we need to add this together with the same thing but at 2,000 and 3,000. So we could in fact do something like sum this for x in 1,000, 2,000, 3,000. So we could do that. Let's see here. How would that actually be formatted? Sum data x, and then we say for x in, and we could do 1,000, 2,000, 3,000, or we could do times 1,000 for x in range, and we do x in range 1 to 4, I guess. There we go. So that should return us the value. So of course we're going to test this against the input, right? We want to test this. We want to make sure that we're actually doing this correctly. So we're going to test this against the sample data that they give to us. So here's the sample input. Of course, when we do the full thing, we're going to be reading from the standard input. We're just going to pass the input to Python, but in this case, we're just going to test and see what the final output is here. Attribute error. Int object has no attribute index. Num.value for num. Where am I? Rotations. Num in dot index for num in data dot index I. Has no attribute index. We forgot to, I forgot to actually set this, wait, hang on. Parse data, deck. Okay, here we go. Of course. We need the index. We need to create the class first. So what we're actually going to do here is we're going to say index int x for x in, and we're going to enumerate. We're going to enumerate that. So we get index x and enumerate this data. And then we're going to return, I guess we should not have a deck yet. And we'll return num index x for index x in data. Okay, that's what we're going to return. All right, what did I do wrong? Parentheses around the comprehension target. This. There we go. Okay, let's try this again. There we go. Okay, so this is 3. So we should get back the value 3. What is the value that the sample wants us to have? Adding these together produces 3. Okay, so that should be the correct answer. Let's test this out on the actual input, on the actual puzzle input. 9,687. Okay. 9,687. Perfect. Okay. So let's continue to part 2, because this is fun. So there's apparently a decryption key. So every single value needs to be multiplied by this number. Multiply each number by the decryption key, by that value. Second, I need to mix the list of numbers 10 times. And the order in which the numbers are mixed does not change. So we need to, that's why it's very important to keep the index there as well, is we're going to base the rotations based off the index, not based off the, where was I going with this? Not based off of the value, right? And it needs to be the same index every single time. So this is actually going to be relatively straightforward to abstract out. So we're going to have in here, we're going to have an n times, and we're going to say for and and we're going to just say for blank in n times, because we don't actually need to keep that value. In range n times, there we go. So for blank in range n times, we're going to do that rotation again, right? Where we rotate that forward. So this will take 10 times as long theoretically. Now, of course, something that we need to do is we actually need to adjust our data here. So in this case, that's our input. So we actually need to say we're going to say data is going to be num we want this to be a dec. We're going to say num index num dot value times, what's the number that we had? What was this number? Okay, so we're basically reassigning the value of the data here, and then we're going to print, and we're going to run this data, but we want to run this 10 times, right? And let's just assume that this is going to be 1 by default, so that this one will run 1 time, and this will run 10 times, okay? So theoretically, this is going to be part 1, and this is going to be part 2. Okay. Number of times, and we keep everything the same. We're still calculating this value. Okay, let's try this again. 9687, so we didn't break anything. That's good. This could take a while because it'll take 10 times as long, right, to do this. There we go. Okay, let's test. Oh, let's test it first on our input data, of course, just so that we don't get something wrong here. Okay, where's our input data? Here's our sample data, not our input data. We're gonna test it on our sample data. Why is that a negative number? Part 2. So we get the wrong answer. Got the wrong answer for part 2. Still getting the correct answer here for part 1, but part 2 is the incorrect answer. Range n times. Rotate. Add the number back in. Okay, it's not the right answer. Figures. Couldn't get lucky. Let's see here. Okay, so we've got the, so what are we doing differently here? Number of rotations, add the number back in to the very end. Rotate n times, we run this data. Oh wait, this is a deck, isn't this? So we can't actually. Okay, so we've got a num object. All right. So basically, I just want to make sure that I'm actually multiplying everything by the values that they're supposed to be multiplied by. Times. Zero, 1, 2, 3, 4, 5. Okay, all the way through it. Through that. Index, there's 5. Oh, ha 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 ha. Ha 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 ha. Okay, so of course, what I did here was the data needs to be basically completely reparsed again, right? Because this is our input. We parse it, then we modified that data, right? So now we would need to reparse it, and we need to rerun it again. So that is supposed to be the correct answer. Oh. So that is the correct answer right there. So that's the correct sample answer. Haha. And the correct answer is going to be whatever this ends up being. Oh, it's going to count through all these. Let's get rid of that. So take a little bit extra time. But yeah, basically we have to reparse the input because, of course, passing that value into the function, it actually modified the data, and then we were basically running it 11 times. So if in this case, if I just ran this another 9 times, I think this would actually give us the value that we're actually looking for. No, because we need to modify this before it actually before it gets run the first time. So anyways, so this should be the correct answer. Let's double check this. And there we go. That's the correct answer. So that's day 20. The biggest thing for me was this data.rotate, right? Rotating the DEX basically to the left or to the right, theoretically. So in this case, everything was rotated to the left, and then we figured out how many more rotations we had to do, and then we rotated to the left again anyways. So there you go. If you have any questions, let me know. Put them below the video. Don't forget to like, of course, subscribe to the channel. There we go. Happy programming. Hope this helped. Have a great day.